Alright guys, so this is going to be the longer question. Should make for a short video though since I took the time to draw it out beforehand. So, well, relatively short, I guess we should say. Okay, apply the molecular orbital theory to predict of each molecule or ion exists in, I'm guessing that should be if each molecule or ion exists in a relatively stable form. So we'll start with A. I already drew out the thing. So what we have to do is take the molecule and break it up into two parts, and then we count the electrons and add them all up. So and once we do all this, we're going to look at this area right here that I keep circling, and that is going to be what we use to determine bond order. And remember, our bond order cannot be 0. Bond order is going to be equal to half of, we'll say, just star, so that's our anti-bonding minus bonding. Right, so remember, it cannot equal 0 or it doesn't exist. So what I like to do, just for a quick look, is if there's nothing here at all, like this first one's going to end up being, then it doesn't exist, or it doesn't exist stably. If they all fill up and there's nothing extra, then you're going to have, like, let's look at the letter B that I have written out here. We have 2, 4, 6. 2, 4, 6. So 6 minus 6 is 0. Half of 0 is 0. So the bond order is going to be 0. So if they all fill up, doesn't exist. You want something to be not completely filled. So looking at this one, there's not much to write here, because if you had H2, which is stable, we know that exists because it's one of the diatomic elements, you'd have 2 electrons, and each one would have 1 electron, and it would look like this. Bam, bam. So that's the ones that we have to play with. 1 up, 1 down. And this would be full. And then, so half of 0 minus 1, well, would be negative 1/2. Or 0 minus 2 would be negative 1 overall, is what it would be. But either way, you have an actual number, you don't have 0. But in this case, H plus has no electrons, so we have nothing to fill in. So the bond order is going to be 0 in this case. So it's not A. That's not the one we want. So for the next one, neon. Neon has a total of 10 electrons by itself. So we have 1, 2 for our 1s, and then for our 2s, 1, 2, and then for here, it's completely full as well. So 1, 2, 3, 4, 5, 6. Same thing over here. 1, 2, 3, 4, 5, 6. 1, 2, 1, 2. Okay. So for most of these, you can actually just look at the last thing, but I drew the whole thing out on the first one so you could see what's happening. Basically, we distribute these evenly. So I have a total of 4 to play with. 1, 2, 3, 4. That's all good and done. That doesn't matter. Same thing here. 1, 2, 3, 4. These are sigma and sigma star, or bonding and anti-bonding. On here we have, it's sigma first, then pi, then anti, or pi anti, and then anti-sigma, or sigma star. So we have 12 to play with. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, if we look, everything is completely full. So we're going to have 0 over 2, which is going to be 0. So that doesn't work. Jumping over to the next one. We have helium-2 plus. So that breaks it down into 2 heliums with a plus charge. So we have, helium would normally have 2 electrons. It has 1 here, 1 here. So putting those in, 1, 2. Oh, look at that. Our bond order is going to be 1/2, right? Or 1, I'm sorry, 1, not 1/2. 1/2 of 2. So it's going to be 1. So yes, this is cool. This is happy. That's all good. That's going to be our answer, but just for clarity, we're going to go ahead and bust on over to this guy right here. We have the two, this is F2 2 minus, so breaking that in half, we have F minus and F minus. All of this area right here is going to be full, and the one that we are going to concern ourselves with is the 2p. So if we look, F minus, that has a total of 6 electrons in the 2p. Same thing here, same thing here, same thing here. Cool. So we have a total again of 12 to play with. So this should look really familiar from last time. I know I'm filling these weird. It's just because I know they're all going to be filled up. Normally it's up, down, up, down, down, up, or I'm sorry, up, down, up, down, up, down, up, down, and then, oh no, that's right, up, down, down. That's cool. Anyways, if we look, it actually works out to be the same thing as neon 2, where you would get a bond order of 0 over 2, which equals 0. Like I said, just look and see. If all of these are full and there's nothing else above, then it's not going to be the right answer. Over here, look, only one of these are full, the other one's not. So yeah, that's going to be stable. This, there's nothing there, so it's not stable. Cool. I hope that helped a little bit. I know I ran through it pretty rapidly. Yeah, let me know if you have questions. You can ask in the comments or just ask me directly.